So we have seen basic built-in data types in Java. We have seen standard control flow in Java. So now let's get down to business. So object-oriented programming. So how do we define classes and objects in Java? So remember that a class is a template, right? So a class encapsulates a data type, the values that are stored in the data type and the functions that manipulate it. An object is an instance of the class, right? So how do we define classes? How do we create objects? And when we create an object, what happens to the values inside the object? How are they initialized? So that's what we want to discuss. So we've already seen class definitions, but the kind of class definitions we have seen have not been very interesting because they've only contained functions which are static. So if we have a real class, a class is intended to create objects dynamically, and each object will have some local data in the form of instance variables. So for instance, suppose we want to store dates. So a date consists of three parts, right? A day, month and year, and let's for convenience assume that all of them are stored as numbers. Right? So a day will be something between 1 and 31, month will be between 1 and 12, and year will be some 4-digit thing typically. So at the top we have this date as the name of the class. So we have this reserved word class which indicates that this is a class definition. Public of course indicates that this class is public. Remember that every public class defined must go in a file of the same name. So if I write this, I must write this in a file called date.java. And the other thing to remember about Java is that, like Python, capital letters matter, right? So if I write capital date as the name of the class, the file name should also start with a capital D. So date.java will contain this. So here at the top, right, this is defined outside. So remember that every function in Java lives inside a class. That's how we wrote the class for, say, the hello world, and even some of the examples that we wrote to sum up arrays and all to illustrate the control flow. But outside these functions, you define these instance variables, and for those functions which are variables which are outside the function, which are instance variables, you have to specify their visibility. So here we are saying that these three values, day, month and year, are going to be instance variables of date, and they're going to be private. That is, for each object will have its own copy of this, but it will not be visible from outside date. Right? So now private is of course a useful thing to have. Public is a useful thing to have. So is there a default? Okay. So if you were very serious about object-oriented programming, you would assume that the default should be private. Everything is private unless you explicitly make it public. Now remember that there is a tension between what is theoretically desirable and what people are used to. So unfortunately, when Java was created, there was some public pressure in some sense to make it compatible or easy to use. So the default is that if you don't say anything, it's more or less public. So private is something that you have to think about and write. If you forget to write public, it's not an error in Java. If you forget to write this, so you will see many examples of Java code on the internet or in textbooks where the word public doesn't appear, and yet that code compiles. So what this means is that implicitly, if something is not labeled as private or public, it is kind of public, so it is visible between within what is called the current package. Now the notion of a package is completely administrative. It has nothing to do with functionality of the code. It's just a way of organizing your code. So it's a bit like libraries and so on, or like putting your files into a folder or your mailbox into separate folders. So it is an organizational unit. So if I don't say public explicitly, then the visibility is public within the current package. And what Java assumes is that all the classes which are defined inside, say, one directory or one folder in a system are all public to each other. So there's a kind of default package. If you write something .java, then all the other .java files in that same directory are deemed to be part of the same package. So that's why you can get away with not writing public. So again, so we will keep seeing this kind of trade-off. So first of all, we saw that Java has used these standard data types like int and float because it is cumbersome to make everything an object. Okay, then we saw that it uses this very strange C-style for loop and switch statement because those are conventional and people are used to them. So here again, because people might not want to be forced to write public and private everywhere, okay, remember the goal of object-oriented programming is not to give you a choice. The idea is that you can be a disciplined programmer without writing public and private. This is what is expected of a Python programmer. But the whole goal is to not give the programmer this choice, to make it the compiler's duty to enforce these things so that code can be type checked at compile time. But still, Java is forced to compromise, and if at all something should be default, it should be that private is the default, but actually public is the default. So if you leave out public, it is public within the package. If you leave out private, it is public within the package. So you write explicitly private, it's private, otherwise you can assume it is sort of public. So now these instance variables, right, will be stored separately in every object of this type. So every date object that we create will have its own copy of this. So there will be multiple copies. Within that object, they will be called day, month and year, but each of them will be distinct from others, right? We can also have public instance variables. As I said, the whole purpose of object-oriented programming and abstract data types is to encapsulate the data. So actually it is not meaningful normally to have publicly available instance variables, because you do not want the internal data to be written or read from outside. Because if somebody is reading your internal data or writing your internal data, then if you change your representation of how you keep the data, then their code will break. Right? So you don't want other people's code to be affected by implementation choices in your code. So this is one reason to keep classes, keep the instance variables private and only allow restricted access through public methods which you control. So now to use a class, we use the class name as a type. So we can define a variable D and say that it is of type date, where date now will be a class which Java knows about. So if I write something like this in one file, Java will go looking for a date.java file because it knows that there must be one such file available to me, because there must be a public class which I'm using. If it doesn't find it, it will be a type error, otherwise it will find it in that file. Right? So this will tell it that there is a declaration here of date, so there must be a date.java with a definition of the class. Now I want to actually create, so this doesn't create anything, right? So this is, we saw in the array case, we just say int a, this doesn't create an array. I have to say new something to create the array. So the new actually comes from here. So for any object, we have to use this word new. So we say d is equal to new date, right? So this bracket, we will see, it is to do with setting up parameters. But essentially you use the word new and the class name in order to create an object of that type. Now we have created an object, it has some private day, month and year. So how do those get set? So one way is for the class itself to provide functions to set it, right? So for instance, inside this class date, I could have a function called set date, right, which takes a day, month and a year, and it sets the instance variables to the arguments, right? So the word this here is specifying that we are talking about the instance variables for the current object. So I am calling this, I will say d dot set date something, right? So this will mean that inside d, it is referring to its own copies of this day, month and year, right? So it's just used to disambiguate which day, month and year we're talking about, as we will see as we go along, right? So this now sets this up, and it will now allow us to update, okay? Now, if there is no confusion about which one we're talking about, I mean, I'm executing this, say, in the context of this date d that I created, then I can omit the this. So if I don't say this and I use the name of an instance variable inside a function, it must be my copy of the instance variable, okay? So this is implicit, but sometimes to make the code explicit, it's useful to use this. Symmetrically, if I want to find out what is currently stored in a date, I can't look it up because it's private, right? So I need a function which tells me, right? So to avoid getting into complications of tuples and all that, let's just assume that we have a function for each part of the instance variable. So there are three integers, day, month and year. So let's assume that there are three functions. There's one function called getDay, which returns the current value of day inside this object. We have getMonth, which returns the current value of month. And we have getYear, which returns the current value of year. So these functions only report the current value, they don't update it. So broadly speaking, we will have, with any class which has these private instance variables, we'll have two types of functions to manipulate the data, one which will update and one which will report. So it is conventional to call the ones that report accessors and the ones which update mutators. So mutation is something which changes, right? A mutator is a function which updates or somehow modifies the instance variable. An accessor is a function which reports something about it. It may not report everything, or it might report a summary or whatever, but it tells you something about the instance variable without touching it. So this is of course a two-step process, right? I have to first create a empty date, and then I have to call this set date variable to set it up. So it would be nice to have a way of doing what we do with other things, right? So we say int I equal to 0. So this is a declaration combined with an initialization. So how would we do this for an object, right? How can we initialize an object when we create it? So this is done through some special functions which are defined inside the class called constructors. So in Java, the constructor is given by the same name as the class. If you remember in Python, the constructor is called init, right? So there's a special function in Python called init, which is called when the class name is used to create an object. In Java, the convention is to use the name of the class itself. So this function doesn't have any return value. Its only purpose is to set up the values when the object is created. You cannot separately call this function date at any later stage, right? It's not a function available to you. It's not a public function. Though it says public here, you cannot say at a later point d dot date something. Okay, this is not allowed. It's an implicit constructor which can be called only implicitly by creating it. So what you say is d equal to new dot date, new date, and then you pass, as we know from Python and the init function, you pass the arguments that constructor expects. So the constructor here is written with 3 arguments, and just like the set date that we had earlier, it sets the instance variables to the parameters that it receives from outside. So this is a constructor. So it is a special function called when an object is created, cannot be called otherwise. Now, one interesting thing about Java is that it allows you to have multiple types of constructors. Here is another constructor where you just specify the day and the month, right? And implicitly it sets the year to be 2021. So this is something where one of the values is set to be a default value and only 2 values are provided. So there are 2 different functions, right? And internally also they have the same name. So technically what Java thinks of as the signature of a function is the name of the function, its input parameters and its output parameters. So here this is called date and it has 3 integers, right? Whereas this is a date and it has 2 integers. So these technically have different signatures. So for Java, these are 2 different functions. So this is what is called overloading. I can use the same name, but I can distinguish between 2 different versions of the function by changing the parameter type. Okay? This is not allowed in Python. In Python, you cannot have 2 different functions with the same name, right? And just have a variation in the, so the way you can get around it in Python is to define some default values. So for instance, you could say y is equal to 2021 here, right? And then Python will say that, okay, the last parameter is optional. If I provide it, I will use it. If you don't provide it, use 2021. But then this also fixes an order. I mean, so you have to provide the optional parameters at the end and the non-optional parameters before and so on. Whereas Java allows is overloading, right? So it allows the same. So here we have done overloading for constructors. So I have 2 different constructors now. I have a constructor in which I provide the day, month and year when I set up the object. There's another constructor where I only provide the day and month and it implicitly provides the year as 2021. Okay, so this is not within my control. Of course, whoever designed the class chose 2021. It might choose 2011, it might choose 1954, whatever it is. But I don't set the year is set implicitly. Okay, so this is overloading. So the overloading idea is not restricted to constructors. It can be for functions in general. Not allowed in Python, is allowed in Java. Now notice that except for setting year to 2021, right? So this is very similar to that. So in a sense, this is a special case of the second constructor is a special case of the first constructor where the year is set to a fixed value. So this can be actually reused in Java. So what you can do in Java is you can make the second constructor reuse the first constructor by passing the d and the m that you get from outside and passing 2021 as the value, right? So what we are saying is that inside this constructor, when I use the word this, I'm saying look for another constructor with this signature. right? So this here refers to myself, right? So I'm saying this is like date, but remember you can't call date, right? You are saying this is just a convention that you use this to say look for another signature with this signature, look for another constructor with this signature, and in that constructor I pass two values which I have got, and I pass a default value of my choosing, but the other constructor requires three values, so it will correctly take these three values and set up the thing. So in other words, the second time I don't have to change the way the assignment to the instance variables is done, right? I'm just piggybacking. So I already have a way to do it. I'm just saying do it with this argument as a default for the third one. Right? So this is a reuse of code. So if I change at some later point how I represent things, then it will automatically be changed if I change only one constructor. I don't have to change every constructor. So that's a general principle of reuse, that if you change something, then that change is automatically reflected everywhere. You don't have to be careful about going everywhere and systematically making it consistent. Now, if you don't provide a constructor at all, right, you just write a class and you don't provide a constructor, then Java actually gives you a default. So it's not obligatory to write a constructor, right? If I don't write anything, then if I say d equal to new date, this will still work. And what this will do is that Java will set default values sensibly. So this is one difference between Java and other languages, right? In most languages, when you declare something, even in Python, until you assign a value explicitly, it has no well-defined value. But in this setting of Java, objects in general, and this is even true of arrays, right? If I create a new integer array in Java, by default, it's initialized to 0. Now, it may not be a great idea to rely on this. It's probably better to initialize it yourself, but this is done. So similarly here, if you do not provide a constructor, then Java will set up this object, but not with random values, but with some specified values, in particular sensible default. So typically numbers will default to 0, booleans will default to false, a string you would think would default to an empty string, but it may default to the value null, which is the equivalent of an undefined object, okay? But in general, this default assignment is done at the object level. So you can get away with not defining a constructor and doing this. But if you have defined these constructors, right? So supposing you have these constructors and now I do this, then what happens? Well, then Java will not forgive you because you have defined constructors. So the default constructor is not available to you, right? The default constructor is available to you only if you have defined no constructors at all. If you have defined even one constructor and then if you call it like this, you must provide an explicit constructor with no arguments. Otherwise, it's an error, right? So when you call a new, the way you call it must match one of the constructors. If it doesn't match any of the constructors, it's like calling a function that doesn't exist. And if you expect to call it with no arguments, you must either provide a constructor with no arguments or provide no constructors at all, in which case you will get a default constructor. So this is to create an object from scratch, right? I create an object and I want to populate its values from scratch. What if I already have a date and I just want to copy it into another date? I want to create a new date which has the same values as another date, okay? So this is something called a copy constructor. So here again you create a function whose name is the same as the class, but now the argument, instead of being the same type typically as the instance variables, is another object of the same type. So I will create a date using another date, right? And what will I do? I will copy the instance variables from the other date. So remember that if I have an instance variable inside an object, I use the object name dot the variable name. So I'm looking at the day, month and year inside D. So d dot day, d dot month, d dot year, and I'm going to copy it to this dot month, this dot day and this dot year, right? So I'm going to copy the instance variables from there to here. So I'm basically taking an existing date D and creating it, right? So how would you use this typically? Well, you would create typically two variables, D1 and D2. Initially, you create one date by concretely providing a date. So you'd say that I want a date which has 12th of April 1954. Then I say I want a new date which has the same values as the old date. So I pass the existing date D1 as an argument to the constructor and it will automatically call this constructor because this type matches, right? I have a date D there and I have a date D here. So one thing to keep in mind here is that remember that these variables are private and yet we are accessing them from another object. The crucial thing is we are accessing them from another object of the same type. One date is looking at another date. Right? So within objects of the same class, privacy is not maintained. Now this doesn't, we will discuss this later, this does not create a problem. Why is privacy and public an important thing, right? So you want to keep the implementation private so that other code does not change when you change your implementation. But if I change the implementation of date, then every object of type date is also changing. So I can update all parts of date which affect this together. So we talked about this right at the beginning, we talked about this object refinement, right? So we said that when you have a bank account, right, then if you want to change the way the transactions are reported, you have to make a bank account more elaborate. And if you did not have it as a class, then you would have to separately check about the functions. But if all the functions that manipulate bank accounts are in that class, then automatically when you change the representative data, you will also change all the functions. So similarly, if I change the way the date is represented in one place, then this object constructor will also change, right? So it's not really, it makes sense to say that private variables can be seen within a class, and we will see other examples of this. But just remember this, that public and private refer to outside the class, not just outside the object, right? Other objects of the same class can read the private instance variables for other variables of the same class. So another subtle point here is that we are copying these things. Now this is the equivalent in Python of copying immutable data. But remember, in Python we saw that if you write L1 equal to L2, right, they are both pointing to the same list, and the same happens in Java also. If I write D1 is equal to, so I could have just said D2 is equal to D1 here, right? So this would have been fine. But then D2 and D1 are not two separate objects. D2 and D1 are two names for the same object. So at the high level, I avoid that by doing a copy construction. But what if these in turn were objects? Then these two will be pointing to the same object, right? So I have a problem of this, what is called a deep copy, right? So superficially I copy the top level, but inside they are pointing to the same object. So if I manipulate something in D1, it will also get changed in D2 and vice versa, right? So we will come back to this later on. So there is a general issue about cloning an object. If I want to take an object and I want to make a copy of it, which is disjoint and does not interfere, how do I do it? So to summarize, as we know, a class essentially defines a type, right? It's an encapsulated type with the variables and the functions that manipulate it. Typically, we expect the instance variable to be private, and then they should be accessed through suitable methods which allow you to read and write them. So these are called accessor and mutator methods. Right? And then we declare variables using the type name as the type, the class name as the type, right? So we write date, which is a class name, and D, and this tells us that D is going to represent an object of type date. And then we use new to create the object, and when we use new, we would like to populate it. So for that we use constructors. So constructors can come in multiple forms, and this is generally allowed by Java, something called overloading. So if the signature of two functions are different, and this could mean the same name but different arguments, they are different functions. So you can use the same name to denote different variants of a function. One constructor can call another, so you can reuse the code and minimize the problems that happen with updates. If you don't provide a constructor, you get a default constructor which takes no arguments and sets sensible values for all the instance variables. And finally, you can use a copy constructor to make a copy of an existing object, but you have to do the copying, right? So here, for instance, this part of the code, you have to decide how you are going to copy. So this issue of shallow copying versus deep copying is in the hands of the implementer. It is not something that Java is going to guarantee for you.